Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. HI AMPL. Enterprise-wide optimization systems. HI operates as a knowledge factory in highly complex mathematical modeling. Its objective is the monetization of its intellectual property, making win-win commercial alliances. For this reason, one of HI's main interests is to make joint ventures with AMPL business partners, and with AMPL to go to market. The solutions offered by HI can support the growth of startups, spin-off companies, or companies already created, to offer solutions to their end users, as part of the digital transformation of companies. The table presents a brief description of the enterprise-wide optimization systems offered by HI, using AMPL capabilities. HI AMPL solutions are integrated into specialized enterprise-wide optimization systems, covering multiple industrial and socio-economic sectors. Industrial enterprise-wide optimization. Industrial value chains can be conceived as multiple links that work as the union of two chains, supply and demand. The supply chain is associated with production activities, while the demand is associated with the business. These chains cannot be thought of as mutually exclusive, as the border that could divide is fuzzy. What is clear is that they are complementary and that their union affect all the value chain. HI models mainly support two types of industrial planning activities. SANDOP, sales and operations planning activities that are carried out periodically, usually every month or every week, to coordinate the selling products with production activities. IBP, integrated business planning, activities that are carried out periodically, usually every 6 months or every year, and aim to perform integrated value chain of the organization planning. The solutions offered by HI to the general industrial sector are based on the integration of following groups of solutions. HI DCO, demand chain optimization. HI SCO, industrial supply chain optimization. HI bio-industrial supply chain optimization, and HI HRA, human resources analytics. S&OP may be constructed based on 8 groups of solutions or systems: production, energy, maintenance, distribution, sourcing, human resources, financial, and sales and marketing. HI view the systems as groups of equations that must be included in the S&OP mathematical problem depends on many factors, so that there is no revealed truth regarding what the S&OP problem is. Since the equations are defined in a database, the configuration of a problem is limited to selecting from the equation store which are the ones that the modeler wants to consider in the model. Sales and operation and financial modeling. The connection of financial models with operating models provides, as a minimum gain, the automatic and coherent generation of the financial statements. As a substantial improvement of the decision-making process, the linking of the financial model with the supply chain models allows to optimize cash flow and treasury management, working capital, tax management, dividends, repatriation of capital, payment of liabilities, the capital and capital structure, transfer pricing, and the analysis of corporate financial risk. Production and energy services planning. Models oriented to the integration of the system of production of goods, transformation of matter, with the systems of production of industrial services, transformation of energy. Mathematical models optimize the production process, including industrial service plants at the tactical level. The union of the SANDOP and ISO models allows companies to link to the production plans the management of environmental restrictions, the management of the carbon footprint, the negotiation of energy in the different markets, and the minimization of production costs through the explicit inclusion of energy costs. Its use includes the design of new electricity supply networks, Integrated production energy planning, emission control, material blending, and fuel blending. Multi-echelon dynamic inventory. Non-anticipatory stochastic programming models, based on random scenarios, to determine the optimal inventory management policies in a multi-link distribution chain. The objective function is to minimize the sum of the expected costs of storage, purchase, transport, and loss demand, considering spatial location of distribution centers, location and demand of end customers, distribution center capacity, purchase cost, availability of working capital. It includes financial risk control concepts. The definition of inventory management policies focus on minimum inventories of raw materials and finished products and quantities to be ordered throughout all the facilities of the supply chain that must meet the orders of the end customer. It is applicable for the inventory management of spare parts. Global sourcing optimization. The main result of HIGSU are the purchase orders must be issued by the organization. For this, a detailed modeling of all the negotiation and purchase processes is carried out, mainly of imported raw materials. It considers in detail the Incoterms for trade between large regions and the special tariff regimes for the promotion of exports from imported raw materials. HIGSU considers conditions of shipment of goods, Incoterms, delivery time, delivery route, delivery times, cargo consolidation, multiple supplier offerings, regulation of each country, production scheduling. HIGSChed aims to produce a detailed schedule, by hour, shifts or half shifts, the operations to be performed on each production line, cell, and machine, including the technical specifications of production, like temperature, speed. Production goals are pre-established, which implies that the first objective is the generation of a feasible production program that ensures compliance with the production goals established by the tactical level. When there are multiple factories, the planning scheduling process involves two steps: aggregate planning using the S&OP model, and detailed production scheduling using individualized sched models for each factory. Maintenance planning and scheduling. Optimization models of the asset maintenance process, to have a safe and reliable operation of the production system to improve relevant operational aspects such as functionality, safety, plant productivity and profitability of the industrial operations. The model proposes maintenance start and end dates for each asset. Mathematical models follow the methodological principles of PHM, prognostic health management. Available to promise in distribution activities. The function called ATP, available to promise, is oriented to the assignment of products to the orders of the final customers and to the delivery trips of said products. High ATP allocate product available in distribution centers, and in short-term production plans to firm or potential orders that expire in the short term, additionally also supports planning of vehicles of cargo and its routing. Industrial Decision Support System. The architecture of a production DSS in an organization is presented below. It is made up of 8 models, and the diagram describes the data flow between models. Traditionally, these models are run with a certain frequency: daily, weekly, bi-weekly, monthly, and the implementation of the decisions depends on the professionals who must validate the results. In some cases, this validation is automatic. The artificial hypothalamus is the evolution of DSS under the Industry 4.0 revolution, and it is the integration of the methodologies of artificial intelligence and mathematical programming. The image shows some examples of screenshots of solutions implemented with the methodologies and technologies managed by HI. Related with enterprise-wide optimization. Optimization of agro-industrial supply chains. HI Bio consistently meets all solutions developed by HI in different areas of application of mathematical optimization models, aimed at the planning and the scheduling of operations to synchronize the primary link, in the farms, with the industrial link, in the factories, of an agro-industrial supply chain, to produce food from the vegetable and the animal raw materials that are developed on the farms. The value chain covers from breeding farms, the transformation of the benefited animals into commercial products to the distribution of such products to different customers in multiple markets. Geospatially, it is made up of networks of farms, slaughterhouses, industrial plants, distribution centers and points of sale. Mathematical models seek optimize the management of the network of supply chains of vegetable raw materials, for example, corn, soybeans, fodder, and animal raw materials, for example, poultry, pigs, cattle, fish. Optimize the planning and scheduling of the industrial operations in the factories, for example, feed production, meat processing, and minimizing costs to achieve considerable savings in the process and increase the profitability of the business. Planting and harvest planning. Models aimed at optimizing decision-making processes related to planting planning and harvest scheduling. Stochastic programming models that include hydroclimatic systematic scenario and financial risk management. Planning livestock farms. The main objective of the model is the planning the optimal operation of a dairy farm. It is a mathematical optimization model that considers the integral process of cow growth, pregnancy cycle and milk production, forage cycle, supply of food, nutrients, cost of production, and sale of milk in a market with dynamic demand and prices. The results are pregnancy cycle of cows, for each animal, forage planting scheduling, rotation of cattle lots in paddocks. Balanced food replenishment. Models aimed at optimizing the planning and scheduling of the supply to the network of farms of balanced feed, or fertilizers for the case of vegetable crops, from the industrial plants that produce them. This process considers the age distribution of living things on different farms, since age determines the type of nutrients they require. The process includes transportation costs and the capabilities of the vehicles to be used in the process. At the tactical level, the models determine consumption goals for feed, or fertilizer. At the operational level, the models establish in detail the transport services that are required. Animals and vegetables collection. Models aimed at optimizing the collection of agro-industrial products and their allocation to commercial commitments, orders and/or bilateral contracts, considering the capacity and availability contracts signed with transport/shipping companies, and the owned vehicle fleet and the enlistment capacities of said products. Bio-industrial available to promise. The problem of planning the allocation of live animals to commercial commitments is to find the number of whole animals and animals per piece that are required to meet demand and reduce costs. The questions to be solved are: when should the whole animal be used/bought/sold? When to cut it into pieces? When to use/buy/sell the parts? Which commercial orders should I assign the whole animals and parts? Which animals from which farm should go to a certain processing plant? Bio-industrial available to promise during demand super peak periods. The problem of assigning live animals to commercial commitments during periods of exceptional peak demand, usually associated with special holidays such as Thanksgiving, Christmas holidays, involves the coordination of multiple decisions to achieve cost minimization to maximize the profitability of sales during the peak season. It involves integrated planning that must cover several fronts. Farm planning, inventory management policies, reconfiguration of the distribution network, product transport planning, and reverse logistics planning, expected. Biomass energy planning and scheduling. Design and implementation of mathematical models that integrate the bioenergy process with the integrated management of one or more farms, in such a way that the economic, social and environmental sustainability of agricultural production is integrated and optimized. The energy produced by the conversion of energy crops, or animal manure, into biogas and/or biofertilizers should be considered, using anaerobic digestion technologies, crop allocation, and animal husbandry practices. In many cases, in a single farm it is not profitable to produce energy, which can change when considering the network of farms located in the same region. Retail solutions. Demand chain optimization. High Market consistently meets all solutions developed by High to optimize the demand chain of the enterprises. The central model is demand forecasting, a generic algebraic Aramax-Garch type model that allows to configure multiple specific models according to the characteristics of random processes that affect the demand for the products and/or services in a specific point of sale. Demand chain tactical optimization, models to optimize the goals to be achieved in marketing and sales activities, in the medium term. The tactical planning models are market share, aimed at analyzing the participation in a market. It aims to identify the model that explain the behavior of the market share of a manufacturer, or a brand, as a function of the market variables. Marketing mix, it helped the decision makers to determine the decisions that will maximize profits derived from the management of marketing events and sales, considering the constraints of the market, for example, budgets, business rules. Inventories policies, defining parameters for inventory management policies, focus on minimum inventories of finished products and quantities to order along all chain facilities that must meet the end customer orders. And demand chain operational optimization, to optimize short-term decisions in marketing and sales activities. The operational models are revenue management, mathematical programming models to management typical problems of pricing, optimal pricing, associated with I. Price lists, 2. Prices over the life of the product, and 3. Prices to be used in an event auction. Salesman portfolio, assign the portfolio that each vendor, physical or virtual, offers each customer, store or virtual marketplace, in the short term, daily may be real time. A seller may be a person, or a robot or a virtual marketplace. Client management optimization, artificial intelligence and machine learning models, to optimize customer relationships. Marketing campaigns optimization, optimization of sales campaigns, mainly promotions, and similar activities. The artificial hypothalamus for marketing and sales decisions, integrates all the models that are part of demand chain optimization suite. Optimization of the transport and logistics chains. High TSO, transport systems optimization, supports the planning and scheduling of distribution operations of materials, or people, citywide and nationwide. It includes transportation and logistics models. High TSO comprises analytical tools according to the hierarchical level of the decisions. Strategic, design the distribution chain, market selection and/or selection of fleet vehicles. Tactical, selection of supplier based on sales offers, transportation services and fleet allocation of markets, and operation, travel program, roads, vehicles, and crews, to urban and national level. High TSO supports specialized systems programming such as collection of agricultural products, passenger transport, maritime, rail systems programming. Some of available optimization models are urban routing, regional routing, mines transport, cash transport, oil and gas products distribution, less than truckload networks, port operations, vessel and industrial facilities coordination, rail operation, fishing operation, and drones routing and management. Optimizing logistics operations in ports. Berth allocation. Decisions, determine the optimal assignment of all vessels to certain sections of the quay wall considering the corresponding vessel lengths and service times. Benefits, reduce the anchoring time of the vessels before berthing at the quay and maximize the equipment productivity of the terminal. Key crane split. Decisions: determine the optimal allocation of key cranes to ships and the ship's sections. Benefits: improve equipment productivity. Stowage planning. Decisions: determine the optimal stowage positions on the vessel for all containers that are loaded and discharged during the journey of a vessel. Benefits: reduce logistic costs. Load and discharge sequencing. Decisions: determine the optimal QC schedule to load and discharge containers. Benefits: improve QC utilization, reduce transshipment time and reshuffling. Yard planning. Decisions: allocate yard block to storing containers. Benefits: reduce congestion and reshuffling. Container stacking. Decisions: allocate block slots to storing containers and determine stacking operations. Benefits: reduce congestion and reshuffling. Vehicle dispatching. Decisions: determine the optimal vehicle assignment and the sequencing of transport jobs. Benefits: reduce vehicle congestion, reduce QC waiting time. Oil and gas supply chain optimization. High oil supply chain optimization consistently meets all solutions developed by high in different areas of application of mathematical optimization models, aimed at the planning and programming of operations in the different businesses that make up the supply chain of petroleum products. High oil integrates models aggregates each of the links of the oil and gas supply chain, to make the chain planning models with a holistic view of different businesses that make up the petroleum product supply chain. For industrial operations, it is composed by the following optimization mathematical models: oil production operations, oil field smart grids optimization, oil blending and transport, oil refining linear model, and industrial service and energy trading. For transport and logistics operations, it consider two types: GOF transport, I, ducts/pipes, and 2, vehicular multimodal, tankers, barges, tank trucks or trains. Every transportation mode may be modeled independently and jointly can connect facilities such as the oil chain. Oil fields, plantations, crude refineries, biorefineries, ports, and consumer centers. The models for pipelines supports planning and scheduling operations. The goal of optimization is to minimize operating costs throughout the whole process of planning and programming operations. They determine the speed of product transfer and discharge pressures, configuration patterns of pumps in the pumping stations, to meet scheduling tenders. It minimizes energy consumption or energy cost or a mixed function of this objectives. Electricity supply chain optimization. The hypothalamus of an oil enterprise is made up of artificial intelligence and mathematical programming models for the four major businesses that make up the oil and gas supply chain: production and exploration, transportation of crude oil, refining, and transportation of petroleum products. High L, high SGO and high gas together and make high power, that is, set simulation models optimal dispatch of electricity and gas systems. High L, electricity supply chain optimization, models designed to support the decisions of the various actors involved in the electricity supply chain. High SGO, smart grids optimization, models designed to support the decisions of the various agents involved in the smart grids business. High gas, natural gas supply chain optimization, models designed to support the decisions of the agents involved in the natural gas supply chain. According to the structure of modern electricity markets, the support of the business decision-making power generation should be seen from several points of view. Central agents, formed by the regulator, supervisor, planner, and system operator. Generators, agents that operate power plants. Distributors, utilities enterprises. Traders, smart grids operators, and industrial companies. High L, electricity supply chain optimization, corresponds to a set of mathematical models designed to support the decisions of the various actors involved in the electricity supply chain, in terms of sectoral planning and business generation. According to the structure of modern electricity markets, the support of the business decision-making power generation should be seen from two different points of view: I, traditional electricity systems and markets, and 2, smart grid systems. High L and high SGO cover all levels of the electricity systems. For the traditional systems, some of the models are: electricity wholesale systems and markets, economic perfect dispatch, economic regulated dispatch, Carnot-Nash equilibrium dispatch, electricity and gas dispatch, unit commitment, electricity dispatch and financial analysis, maintenance optimization of electricity assets, maintenance of regional national grid, electricity supply chain design, and risk management, and energy trading and risk management. For the smart grids business, some of the models are: forecast of renewable energy sources, forecast of electricity demand, smart grid economic dispatch, smart grid unit commitment, smart grid network design, smart grid network reconfiguration, electricity trading, and risk management, maintenance smart grid assets, and dynamic workforce scheduler. High power and high SGO integrate them models and information systems around a common data model, allowing models to be connected automatically through the database or through RAM memory, integrating them as an artificial hypothalamus for an electricity company of wide coverage. Cities and regions. Analytics, smart and sustainable. High RPO, regional planning optimization, is a set of mathematical models to support planning regions formed by urban and rural areas with a high degree of integration. The model's mathematical programming are oriented to land use urban planning. It determines the spatial relationship between the inhabitants, companies, social systems equipment, and transportation systems, so scientifically that project what the future development of the urban's regions. Land use urban and rural planning, it integrates the RPO-URB with FOSSUM, forest and agricultural sector optimization model, modeling in a nonlinear programming dynamic model for integrated planning of urban and rural regions. Regional economic computable equilibrium, it models urban and/or rural regional economies based on concepts of computable general equilibrium through the simulation of techno-economic input-output systems. Location/use of social infrastructure, it determines the optimal network and use policy in the development of master plans of social infrastructure such as schools, hospitals, police stations, libraries, solid waste, public space, food supply, etc. Regional food supply planning, it simulates the supply of food to cities based on the optimization, design and operation, of the logistics chain that is required for this purpose. Public project management support, based on a computable general equilibrium model, CGE, to simulate the evolution of the economy of the city and its area of influence as a result of implemented investment projects. Water resources planning and scheduling, a comprehensive system of water resource planning oriented to the optimal regional planning in all aspects related to the intensive use of water resource. The model addresses the multiple uses provided and/or for the control and resource management. Public health management, mathematical methodologies for epidemic management based on high complexity mathematical methodologies will prevent the most deaths. Education optimization. As part of the services offered by Hi-Edo, the following stand out. Scheduling timetables for educational activities. Allocation of resources, teachers, classrooms. Scheduling timetables for course exams. Medium-term resource planning. Student collection/distribution routing. Assigning students to educational institutions. Location and capacity sizing of the headquarters, and students' food supply chain optimization. The mathematical models may be customized for special business rules of educational institutions. Financial enterprises optimization. High bank corresponds to a set of mathematical models aimed at supporting the decisions of the different agents involved in the financial services supply chain. Assets and liabilities management. Financial models provide a substantial improvement to the decision-making process. The linkage of financial model with models of supply chain allows to optimize I. Cash flow and treasury management, 2. Working capital, 3. Fiscal management, dividends, capital repatriation, payment/prepayment of liabilities, 4. Capital and equity structure, V. Transfer prices, and VI. Corporate financial risk analysis. It manages the risk based on CARE, conditional value at risk, control. Portfolio risk concentration, its goal is to guarantee the financial health, while maximizing its profits through the optimal management of a portfolio in which the decision maker determines the distribution of their investments according to the expected revenue, the correlations between revenues and the risk of the different decision alternatives. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.